In this video we will discuss about two sums related to de Broglie's equation. So in last class we discussed about de Broglie's equation. Okay, then let us see the questions. It is given that find the ratio between de Broglie's wavelength of proton and alpha particle with same kinetic energy. Okay, the important thing of this question is that same kinetic energy. So if it is mentioned same kinetic energy, we will use the formula related to kinetic energy, means related to capital E. Okay, now what are the two particles? One is the proton and the other one is the alpha particle. So alpha particle means that is nothing but it is a helium nucleus. So inside helium nucleus, what are the particles we have? We have two neutrons and two protons. Okay, so that means alpha particle means it is 2 neutron plus 2 proton. Now the question is that if there are 2 neutron and 2 proton, what is the mass of alpha particle? Remember that in kg the mass of neutron and mass of proton are nearly equal. So if it is nearly equal, we can say that mass of alpha particle is equal to 4 times the mass of proton. Okay, 4 times, because 2 neutron 2 proton means it is nearly 4 proton suppose. So mass of alpha particle is 4 times the mass of proton. So this is the concept that we have to use in this sum. Okay, so how to solve now? What you are asked to do? You are asked to find out the ratio between de Broglie's wavelength. So lambda p, that is the de Broglie's wavelength for proton. The formula is h divided by root over 2 me. Now here I have written mp. mp means mass of proton. Okay, then for alpha particle, lambda alpha, h by root over 2 m alpha into e. Alright, mp stands for mass of proton, m alpha stands for mass of alpha particle. Now just now I told you that mass of alpha particle is equal to 4 times the mass of proton. Okay, this one. So that is why in place of m alpha we can write 4 mp. So after doing this one, means dividing this with this, we get this one, right? So in this equation what we will do, we will substitute m alpha by 4 mp. Other terms will get cancelled, 2 and e will get cancelled, because here it is given that same kinetic energy. That is why here also we have written e, here also we have written e, and it will get cancelled. So after calculation, mp will also get cancelled. We get root over 4, that means it is 2. So the ratio comes as 2:1. Okay, so this is how we can solve this type of sum. Next one. Okay, so what is the difference in these two questions? You have to see that. Find the ratio between de Broglie's wavelength of proton and alpha particle with same potential, or the question may be like under same potential difference. Okay, so which thing is same here? That is the V. So this time we cannot use this formula, but we have to use this formula. We discussed in last video about this formula also. So lambda p will be h by root over 2 mev. Here I have written mp. mp means mass of proton, e means charge of proton. Okay, now for alpha particle h will remain same. In place of mp, what we will write? 4 mp, right? Means m alpha, same thing, m alpha means 4 mp. So fine, this much is alright. Now in place of e I have written here 2e, because just now I told you that alpha particle is a combination of 2 neutron and 2 proton. Neutron has no charge. Okay, so it will not contribute to charge, but proton has a charge. And how many protons we have in alpha particle? 2 protons. So what can be the charge of alpha particle? 2e. Charge of one proton I have considered as e, so charge of alpha particle where we have 2 proton, it will be 2e, and v will remain as it is because it is given same potential. Alright, now simple calculation. Again, just like the previous one, you will take the ratio lambda p by lambda alpha. Everything will get cancelled except 8 will remain. So 8 means, since it is under root, if you take the ratio, it comes as 2 root 2 is to 1. Okay, So this is how we solve this type of sum. Another thing is there, that is the last topic of this chapter. It is a use of photoelectric use of photocell or photoelectric cell. Same thing, photocell or photoelectric cell. So uses means, see, we can use a photocell in different purpose. Photocell main you can say that principle of photocell is that it converts light energy into electrical energy. Alright, because if you remember, we discussed about photoelectric effect, isn't it? There is a vacuum chamber, okay, there is a this kind of chamber. Then what we have a glass window, right? And then there will be two plates, okay. Then through this glass window, what will happen? Light will fall in the plate, and finally the electron from this plate will move in this direction. Alright, so electrons are moving means what we are getting? We are getting current, and that current how we are getting? In expense of light energy. So in photocell, light energy, since light falls and that light finally produces electron or current, we can say that here light energy gets converted to electrical energy. That is the main working, main principle, not working, main principle, okay. So this photocell, it is used in different purposes. One is like in street lights. In street light, when it is dark, the street light, it starts, or it starts glowing by itself, right? How and why? No one is there to switch on a street light, isn't it? It just starts by itself, and there it starts by itself means there photocells are used. Okay, so one use of photocell is that in street light, to switch on and switch off street light, photocells are used. Another is that is in burglar alarm, photocells are used. Then in counter means in this one, in auditorium, okay, in auditorium as counter it is used. As counter means it counts people, that how many persons are entering in a conference hall. So in this way it goes on, or in this way it is used, okay. Another some few uses are there. I will give you the uses, okay. Just after this video I'll send you one photo, where one picture where you will get the uses of photocells. So this one you can just remember. So here we have completed this chapter. So in next video we will discuss about next chapter, which is this one, optics, okay, the first chapter of optics.